Metallurgy and materials engineering form one of the foundation stones of human civilization. From metallographic examinations to electrolytic plating, this discipline has a vast chemical vocabulary, but it also harbors serious dangers. When we think of industrial hazards, we imagine massive explosions or glowing red metals. But the deadliest threats in engineering don't roar. They don't explode. They seep into your skin, completely unnoticed. Today, we are looking at two of the most insidious chemicals in the metallurgical world: hydrofluoric acid and hexavalent chromium. These are the silent assassins. Let's start with a chemical that is widely used in etching aluminum alloys with Keller's reagent, industrial pickling of titanium, and SEM sample preparation. Hydrofluoric acid, or HF. Contact with HF is one of the most frequently encountered fatal accident types in metallurgy labs. You might think you know how acid works. A strong acid burns your skin, and you feel the pain immediately. But HF shatters the illusion that a weak acid equals less dangerous. What makes HF uniquely terrifying is the behavior of the fluoride anion. While normal strong acids cause local tissue destruction solely through the hydrogen ion, the fluoride ion in HF rapidly passes through skin and mucous membranes, causing systemic poisoning. If you are exposed to a concentration below 20%, it starts completely painlessly. This creates a false sense of security. You might not feel anything for an 8 to 24-hour delay, but underneath your skin, a microscopic nightmare has already begun. First, there is weak ionization, where the hydrogen fluoride molecule splits into hydrogen and fluoride ions. Once inside your body, the fluoride hunts for calcium, combining with it to form calcium fluoride. The acid is literally binding the calcium in your body, turning it into an insoluble trap. This causes hypocalcemia, cardiac arrhythmia risk, and eventually, bone necrosis, the deep destruction of tissue and bone. It eats your bones from the inside out while you feel absolutely nothing. By the time 24 hours have passed, it becomes life-threatening. In fact, if just over 2% of your body surface area is exposed at high concentrations, it is fatal. Our second silent assassin doesn't just destroy the individual, it destroys entire communities. Enter hexavalent chromium, or chromium-6. In metallurgy, chromium trioxide is the core component of hard chrome electroplating baths. But its darkest chapter wasn't written in a lab. It was written in Hinckley, California, between 1952 and 1966. Pacific Gas and Electric built a natural gas compressor station and specifically added sodium dichromate to the cooling water to prevent rust. For over a decade, they dumped this wastewater into unlined ponds. The groundwater plume of contamination grew to 2 miles long and 1 mile wide. PG&E notified the local water board in 1987, waiting 20 years after the 1952 to 1966 dumping period. But what happens when humans drink this water? The chemistry is brutal. The chromate ion enters the cells through phosphate channels. Inside the cell, it reduces, causing massive DNA damage. It creates chromium DNA crosslinks that lead to mutation and lung cancer. It even causes epigenetic changes, permanently altering gene expression. In Hinckley, the chromium-6 in the drinking water was over 700 times the safe limit, creating a massive gastrointestinal cancer risk. This corporate failure resulted in the largest individual lawsuit payout in U.S. history at the time, a $333 million settlement in 1996 for over 600 people. You might know this as the famous Aaron Brockovich case, which later became an Oscar-winning movie. But movies have endings. Reality doesn't. Hinckley's population dropped dramatically, slowly turning it into a ghost town. These silent assassins work on a microscopic scale, altering DNA and melting bone. But what happens when engineering failures don't just poison a town, but annihilate an entire ecosystem? In Part 2, we will leave the microscope behind and look at the mega disasters, The day 100,000 cubic meters of cyanide drowned a river, and the era when industrial skies rained sulfuric acid. Subscribe to Neon Flow and never look at a chemical the same way again.